All right, hey guys, Mr. Kyle Myers Mathematics, and let's just jump right into it. This is a worksheet on solving systems of equations by substitution. I did a worksheet on elimination last time in two parts, the first page and then the second page. So this one will probably be the same way, probably be the first page and then the second page, so that way each video is not too long. But going to go through all the questions on the first page of this one today, and then for next week we'll have the other side. We will break on through to the other side. So with elimination, you can go watch it, but basically you want everything to be lined up and you want x's and y's to be canceling. When you're substituting, you don't need that to happen. It's okay if it does, but you don't need that to happen. Really what you want to happen is you want a variable to already be solved for. So the goal, if it isn't already like that, is to have a variable solved for. To have, that's sort of the setup, have a variable solved for. If we don't already have a variable solved for, which we probably will get to at the end of this page, maybe, then you want to solve for a variable. So you want to solve. I mean, you're having to solve anyways, but we'd have to solve for a variable if one isn't already solved for. We do already have a y solved for in the first equation. So then what do I do with that? Well, let's say that is the blue equation, and the other equation is the red one. If I can get it to go away here. There we go. So let's say we have blue and red, right? Blue pill, red pill. So in the red equation, I have negative 2x minus 3y. However, I already have y solved for in the other equation. So this is substitution. It's a little weird, but what we're going to do is basically if you have y solved for, it's like you take everything that y is and you plug it in, because go over here. There's y. There's y. It's the same y. You can't use the same letter to mean two different numbers. You're not supposed to. I mean, I guess you could, but it wouldn't be something you would want to do, and you'd probably get marked off for it if you did that. You want to use a letter that means the same thing. So whatever y is, whatever it's supposed to be, excuse me, whatever y is supposed to be, it's the same. So the y that's right after the 3 in the red equation is the same exact thing as the y that's in the first equation. And I know that it's equal to 6x minus 11. That y is equal to 6x minus 11. It's just like when, you know, when they're like a is 2 and b is 3 and c is 4, and then you plug in the numbers and then you simplify. I remember doing something like that. Well, when you did that, that's basically exactly what we're doing here. We're plugging in stuff. We're plugging in 6x minus 11 because that is equaled to y. And then I just proceed with the rest of the equation like normal. So it equals negative 7. So notice I'm just rewriting the red equation, but inserting the blue equation into it. Or you know, one side of the blue equation. So you take one side of the blue equation and insert it into the red equation, and it makes one new equation. So this is going to be now a purple equation, right? Red and blue make purple. So now it's a purple equation, and I solve it. So then that's 3 times 6. So it's going to be minus 18x. 3 times 11. They're both negative, so it's going to be positive 33 equals negative 7. Looks like I've got some like terms here. I've got some x's. Negative 20x equals negative 7. I can subtract 33 from both sides. Okay, so that goes away there. X equals negative 40. And then I divide both sides by negative 20. It looks like I'm going to get 2. 2 times negative 20 would be negative 40. All right, cool. So that's one of my answers. I box it. normally if I box something, it's a final answer. And if I circle it, it's kind of like important, but it's not part of the final answer. Usually the thing you box is the final answer. X equals 2 is not the only final answer, but it's part of the final answer, so I still box it. And then I just plug back in. And the cool thing about substitution that makes substitution a little bit better, I think, maybe, than elimination. If you like elimination better, that's okay. I do too. But I think substitution is like slightly better. If you were to do like 1,000 math problems with one one method and then 1,000 more with another method, oh, that sounds terrible. But if you did, you would find that you'd get the answer a little bit faster with substitution method. Maybe like 55 to 60% of the time. So it's not like a lot better than the other method, but I think out of the two, it's probably a little bit better. I just like elimination because of the way it works, but substitution actually is pretty nice. So they're both good methods. I would recommend knowing both. Here's what we're going to do. We're going to plug it back into the blue equation. Y is equal to 6. X is 2, we found out, minus 11. So y is equal to 12 minus 11, which is 1. And there we go. We solved it. All right, so let's do it again. Encore. We got to have a blue and a red. So here's our blue. And then the other one is our red. So we're going to be inserting the red, the x minus 1, in place of the y. So this, I'm going to circle it with red here. I'm going to replace x minus 1 where I see the y in the blue equation. Okay. So I'm going to say 2x minus 3, and then I'm going to put the x minus 1 here, and then it's equal to negative 1 still. Equals negative 1. Okie dokie. Red and blue make purple, so now it becomes purple. And let's do that. There we go. And we distribute 2x minus 3x plus 3 equals negative 1. So that's going to be negative x plus 3 equals negative 1. Negative x, I'm going to be subtracting 3 from both sides. X equals 4. All right, then I just plug it back in. So y is equal to, x is equal to 4. So that's 4 minus 1, which is 3. Y is equal to 3. There we go. All right, that one wasn't as bad as 1, I think. But I also kind of showed more of my work for number 1. So I don't know. I still feel like it wasn't that bad. I feel like 2 is easier than 1. It happens sometimes. Okay, let's continue on with the same logic here, blue and red. All right, so there's blue. That one's already solved for, so I'm going to be inserting the negative 3x plus 5 into where the y is in the other equation. All right, so this is going to be my main equation here, 5x minus 4. But then I plug in my y stuff, negative 3x plus 5. And then I go back to red. Okay, and then that's equal to negative 3. All right, and then red and blue make purple. Excuse me. And then we have that. 5x, sometimes my 5 looks like 3s, sorry. 5x plus 12x minus 20 equals negative 3. 5 and 12 make 17. Add 20 to both sides. So it's going to be positive 17. And then x is equal to 1. What? All right, so then we want to plug that in. Plug it into the equation that already had the variable solved for. That's going to be the easier one to plug into always. Pretty sure always. I can't think of any exceptions. I suppose it's possible, but like, pretty sure that's what you want to always do, is just plug it back into the one that's already solved for. All right, again, once more. So we'll do this one in red and blue, but then I think at this next juncture here, I'll switch to 2 different primary colors. We'll keep you on your toes a little bit. So there's our blue equation. negative 3x minus 3, and then I'm going to put the y stuff right there, and then that's going to be equal to 3. Oh, everything has a 3 in it. I can actually do a little bit of a shortcut. I don't know if I will or not, but I could. This is the red equation. That's y, so that's y stuff. That's going to go right there. So that's going to be negative 5x minus 17. Okay. And then we go to purple. Yeah, I think I'll go ahead and just solve it normally. I could divide everything by 3, but that's fine. So negative 3x plus 15x. What is that? 51? Yeah, I think that's 51. Plus 51 equals 3. Okie dokie, that's going to be 12x plus 51 equals 3. Then I want to subtract 51. So that's going to be negative 48. And then divide both sides by 12, and I get negative 4. All right, and then I just plug it into the second equation here, negative 5. X is negative 4 minus 17. So that's 20, positive 20 minus 17, which is 3. All right, cool. So for the next set, we're going to do that same thing there. And actually, we're going to end up, we'll probably just do the same color for the next 6. Yeah, maybe. I don't know. We'll see. So we're going to do blue and yellow. So blue and yellow make green. So I like blue. We're going to stick with blue. This one actually won't be that bad because this one's already solved for. Not only is that something I can circle. Oh, I tried to Control Z that and it did not work. I forgot Control Z does not work on this. There we go. Okay, so I'm actually going to box that because that's one of the answers. So this one will not be too difficult, I don't think, because we're still going to be plugging that in. But yeah, I mean, there's not really going to be a whole lot to actually solve for here. 4x minus 3, and then we put the y value in there, which is a blue y value. So it's the y value of negative 2. And then that's equal to 18. Blue and yellow make green. So we have 4x plus 6. 4x is equal to 12. X is equal to 3. And then we're actually done. We're actually done because they gave us one of the 2 answers at the beginning. Now, this would be a perfect question to show you how to check your answer on. Oh, no, it wouldn't, because you would need a more standard type equation to check it. I guess you could plug it in, but we would want to plug it into the other one. So never mind what I said. Sometimes you can check your answers by plugging it back into the other equation, the one that you didn't just use to get the second letter out of the 2. But this one's not a good one to do that on, so I take back what I said. Let's see, there's our yellow. And here's our blue. So negative 3x minus 2, and then we put our y stuff in there, and that's equal to negative 12. Okay. So that's going to be our y stuff. So our y is right there. Y stuff is right here. 5x minus 7. And then we go to green. Okay. So we're going to distribute. That's going to be negative 3x. 2 times 5 is 10, so that's minus 10x. 2 and 7, those are both minus, so it's going to be a plus 14. All right, negative 13x plus 14 equals negative 12. We're going to subtract 14 on both sides. Negative 26, x is equal to 2. Then we plug it back in. So we'd say y is equal to 5x, x is 2, minus 7. Y is equal to 10 minus 7. I am going to go ahead and solve this one like how I was saying I was going to do on 5, but it just wasn't the right time. I'm going to go ahead and do that now. So if you want to check your work, we just plugged in the x value of 2 into the yellow equation to get the y value. We need both the x value and the y value, unless they say they only want x or y. If they just say solve it, then they want both. If they don't tell you which one they want both. But you can check it. You can check to make sure your work is right, because it's actually possible that my x or my y could be wrong. It's possible. However, it's like almost impossible to get the answer wrong by doing this one little extra step here. So here's what we would do. You go to the other equation. The equation we just finished using was the yellow equation. So we go back to the blue equation, plug in both answers. So we plug in the x answer and the y answer. And this is how you can find out if you're really correct or not. That's going to be -6, and that's going to be a -6. -6 minus 6 is -12. And there we go. Now we have a lot of confidence that that's our answer, because this little tiny extra step that wasn't even solving, it was just simplifying. I was just trying to confirm that the left side was equal to -12. So it wasn't actually really even solving anything. When you do that, and it takes only a couple steps, and it takes like one step if you're able to use a calculator, it gives you like, it makes the likelihood of you getting the answer right very close to 100%, like 99.99%. Like the amount of the number that they put on the antibacterial soaps kills over 99.999% of bacteria. That's how likely you are to get the answer right once you check it at doing this little extra step. Before that, the likelihood of getting the problem right, I mean, it varies from person to person, but like, I don't know, maybe 70-ish, 70-ish%. I mean, you know, it just depends on where you're at. So everybody's going to have a different ability level, so it really just depends on person to person. But I would say the average for somebody who's like just learning this still, around 70 maybe, give or take. Yeah. So you're increasing your likelihood of getting the problem right by almost 30%, with only doing like one extra step. That's a pretty good increase for not a lot of work. So highly recommended. Okay, so actually I might switch colors again, because now we're diving into the realm of, well, maybe not. We're diving into the realm of we don't already have the variable solved for, so we have to solve for the variable. So for instance, this one right here. If the variable doesn't have a coefficient, and by doesn't have, I mean it's you know, it's 1, right? So all of you super technical people out there, yes, technically it has a coefficient of 1. But if there's no number, if you can't see a number in front of one of the letters, right? So for number 7, there's no visible number in front of the y. There's no visible number in front of that x. There's no visible number in front of that y or that y. That's the equation you want to solve for, because you only need to solve that with one step instead of with 2 steps. You can solve for whatever letter you want. You do you. But you want to solve for the letter that's going to be the least amount of work, because you want to do the least amount of work possible and get the right answer. I think that sounds like a good idea. So we should definitely do that. So what we would do is, let me just copy this over real quick. So -4x plus y equals 6. And we want to add 4x to both sides. I don't know what x is, but I can still add any amount of x's I want to both sides. And now I have that. Cool, so now I have y solved for. And then I can plug it into my other equation, my blue equation. So I just plug it into my blue equation, so -5x minus y. You still have to have parentheses. Don't forget to always use parentheses. So minus y is equal to 4x plus 6. And then that is equal to 21. Okie dokie. And so then we have -5x minus 4x minus 6. Okay, that's -9x minus 6. And then I want to add 6 to both sides. So it's going to be 27. And then x is equal to -3. See if I can box that without. I had to cut into the next problem a little bit, but it's all good. It's all good. So then x is equal to -3. And I want to plug that in over here. -3. It's -12 plus 6, which is -6. Ta-da! Okay, so it was a little bit more work but not a lot. It was basically one extra step if you solve for the one that doesn't have a visible number in front of it. Okay, so we're going to do the same thing in the next one. So here's this guy. So we're going to add 2y to both sides. So x is going to be equal to 2y plus 11. Almost put equals 11. Plus 11. Okay, got that solved for. And then we go over into the blue equation, which is now this one. The blue equation. Negative 7x minus, oh, wait, hold on. Go back. Bloop, 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 bloop. We're plugging in x, not y. JK, LOL. Okay, so I'm going to put the x stuff right here. Minus 2y equals negative 13. Y stuff. Okay, so, oh, and then I forgot to circle this. That's the yellow equation, if it wasn't already obvious by now. And then that's 2y plus 11, close parentheses. All right, now we switch to green and finish this out. Okay, so we distribute the negative 7, negative 14, and 7 times 11 is 711, or 77, minus 2y. Okay, put the y stuff together, negative 16y. Okay. Gonna add 77 to both sides. So negative 13 plus 77 is actually the same thing as 77 minus 13, which is gonna be 64. And then that's gonna be negative 4. All right, so we got that. And then we plug that in to negative 4. So that's gonna be negative 8 plus 11, which is 3. All right, last two, we're rounding it out here. Rounding it out, almost done, almost done. So here's our yellow equation. We want to solve that for y. So we want to add 5x to both sides. Okay, done, solved for. Now we plug it into the blue equation. So here's our blue equation. And we have our yellow equation solved for y. So we're going to be plugging in for y. So negative 3x plus 6. And then I'll put my y stuff right there, equals negative 12. So then my y stuff, 5x minus 2. And blue and yellow make green. So negative 3x plus 30x minus 12 equals minus 12. So it's going to be 27x minus 12 equals minus 12. If we add 12 to both sides, we end up with 0. Oop, there we go. We end up with 0, so then x is 0. Because if you add 12 to both sides, it's 0. And then if you divide 0 by anything, you get 0. So x is just 0. And if x is just 0, then that's going to be negative 2. And yes, I showed all my work for it, even though I didn't really need to. But, you know, just in case. All right, last one, last one, last one. By the way, if this stuff has been helpful, of course, you'll want to, you know, like and subscribe and all that good stuff. But also, just let me know how I can help, what I can do. If you are taking a particular class, any class that you're taking between Algebra 1 and Calc 2, I can help with, or sorry, Calc 3. Just let me know. If you want to see a particular problem solved out, I can make that my next video. Or I've been thinking about doing like YouTube tutoring, like just go live on YouTube and then just tutor whoever shows up, and then, you know, just kind of have like a lesson in place, like just in queso. But just kind of do something like that, where like we do like a group tutoring session on a particular topic or something like that. So let me know if that sounds helpful. I've also got a bunch of resources on my website, myersmathematics.com. So go check that out as well. One of them, I think it's on the main page, is called The 5 Math Mistakes Everyone Makes and How to Avoid Them. You can go grab that on my website. Yeah, so that's it. All my plugs. All my free stuff. So 3x minus 8, and then we want to plug in our y value, so I'll do that in a second, equal to 24. Okay, and then we've got 5x minus 3 that goes in place of the y. Blue and yellow make green. So then I've got 3x minus 40x plus 24 equals 24. Looks like I'm going to end up with the same answer as number 9, because that's going to be negative 37x. Not that it matters that much, because if I add 20 or subtract 24 from both sides, looks like x is going to be 0. So x is going to be 0, and then y is going to equal 5 times 0 minus 3, which is 0 minus 3, which is negative 3. I'll skip some of the steps there. And there we go. So that was it for that. And you can check me if you want. Here's the answers. Sometimes I forget to scroll down to the answers. If I do, you're welcome to yell at me. Turn on the caps lock key and let me know how you feel about that in the comments. I dare you. So yeah, if I forget to do the solutions, you can just Google it. You can Google these worksheets and they pop right up and they've got all the answers on them. So no worries, no worries. Oh, one of the answers is that there isn't an answer. Fun. But that won't be till next time. So look at that. Zeros for x's. Haha. Take that. So those are the answers to the questions, just to check. If I miss anything, let me know. It's possible. I didn't check all of them, so, you know. Remember what we said, 70% chance? You know? I think for me it's a tad higher than 70%. Just saying. Just saying. But there's always a possibility that I get one wrong here and there. So let me know if I did. Turn on the caps lock key and tell me how you really feel. But in the meantime, I'll catch you on the flippity flip, and have a blessed day, y'all.